So what we'll see here, and I think I'm not going to do too many of these ones that are pretty straightforward. Just please don't ever try and reduce by canceling something that looks the same top and bottom. The only thing you can reduce is something that has been factored. If it's connected by a plus or minus, it can't be reduced. So I guess I've started on this one. let me give you some more to chew on here. If you factor this, you should get an x plus 4 and an x plus 1, because the two numbers that multiply together to get 4 and add together to get 5 are 4 and 1. This is a factored form. These can be reduced now, as long as you can find something that can be matched with it down at the bottom. This can be factored. If you use a diamond problem, or just look at two numbers that multiply together to get negative 12, add together to get positive 1. A positive 1 means it's a 3 and a 4 because they're 1 apart from each other. Since that's a minus, it's got to be a plus and a minus. It's a positive 4 and a negative 3. So x plus 4 and x minus 3, those are your factors. The x plus 4s can cancel, because what you're doing when you cancel them is you're saying x plus 4 over x plus 4 is equal to 1. It reduces to be the same thing. Now, because it's times, a 1 times this isn't going to change the value. A 1 times that isn't going to change the value. But if you're saying that this is a 1 plus something versus a 1 minus 12, very different. And I mean, that's kind of a simplistic way of explaining it, but that's essentially it. You're reducing to something that is times other stuff, and a 1 times other stuff means x plus 1 over x minus 3 times 1 times this is going to be the same as just this by itself. All right. So then there's other different types of factoring that you can do. For example, this can take out a 5x. You're left with a 2x plus 1. You can take out an x squared. You're left with a 2x plus 1. Okay, coefficient of 1 there. These can be reduced now. Okay, you couldn't reduce anything before that, and in fact now you've got an x left over with two of them down here. Cancel the squared and leave it with the first. Your answer is 5 over x. And then the last thing I'd like to show you here, you need to be able to factor something like that that has a coefficient out in front, and I do the diamond problem here. That times that gives you 6x squared. The 7x goes on the bottom, and we're looking for two things that can multiply together to get that, add together to get that. That would be a 6x and a 1x. I chose the bottom because all pluses are going to make it easier to kind of factor, because you got pluses and minuses up here. Now, these are not your factors. These are not the source of your factors. These are a replacement of the 7x. Okay, so we're going to rewrite this thing, but with 4 terms instead of this, this, and this. It's a 3x squared. Instead of 7x, we're using these guys. That's the replacement. Plus 6x plus 1x, and then plus 2. Now we're going to group this pair with that pair and say I'm going to factor something here, factor something there if I can. And we should be able to. If we're giving you these problems to work on, they are factorable. Take out a 3x. We're left with an x plus 2. I take out, it looks like nothing, but go ahead and write a plus 1, because you can always take out a 1 even if nothing's factorable. You're left then with an x plus 2. The benefit of putting the plus 1 here is that, yes, I can take out an x plus 2 for both of them. But what are you left with? Well, if you just have a 3x and then this parentheses, you might miss something here. But it's a 3x plus 1. And those are your factors. Now, you say those are your factors. Now, you've got to do the same thing up here. We don't give you much room. Let me just make a suggestion. Okay? If I'm giving you something on top that factors with, that hopefully reduces with something on the bottom, and you look at your options, one of these, it's impossible for one of these to go into the top. I'm going to point this out. The 3x cannot go into 2x squared. Okay? You can say 1 goes into 10, but 3x will not go into that. So this is not one of the factors. So then you look over here and say, well, can x go into 2x squared? Well, yeah. How about 2? Does 2 go into 10 or negative 10? Well, sure. So both of these, the outer terms go into both of these outer terms, which means this is potentially a factor. Now, I'm not doing the diamond followed by the pairing, followed by all the stuff, but I'm suggesting that of these two, this is the only one that could be a factor. So let's say, okay, well, what if that was a factor? Okay, I'm working backwards here. I went through the process here, and I'm saying now, if this is a factor, then what does this term have to be? This is a product of the first term times the first term. Well, if I got a 2x squared, x times what would give me that 2x squared? Well, 2x. 2x times x gives me 2x squared, right? Now there's a bunch of things that go on to give me this middle x term. But this term will always come from the last two terms. So if this is a 2, 2 times what's going to give me a negative 10? Well, that's hopefully easy. That's a negative 5. Okay? So this times this gives me that. This times this gives me that. Of the FOIL process, the F gives me this, the L gives me this, the O and the I is the outer and the inner, and those two things right there give you that middle term. Here's your minus 5x, here's your plus 4x. 4x minus 5x gives you that. So that kind of checks off that, in fact, these are your factors. You didn't have to go through the diamond box, kind of diamond pair, whatever. So you said, I think this is probably going to be the factor, so it turns out it is, and these then it turns out are what you have left. Something that you can consider. It doesn't work every time like that, but it does save you time, and it gives you a bigger picture of what's going on.